Hi everyone, my name is Shruti and very warm welcome from TechPledge Consulting. Today we are going to talk about the most asked topic of the day, that is Kubernetes. Many people keep coming to me back about asking about those small terms that we use in Kubernetes and how one is different from other. So here in this video, I have tried to explain each of them in very simple terms. So let's see.
So before we start, let's have a quick recap. So till now, we spoke about how we moved from a traditional server to a hypervisor, and then we moved to cloud, and then now we are on container. In fact, so many companies have already moved from a physical data center to container environment. And when we talk about the real data center, we are worried about so many other things like orchestration, load balancing, auto scaling, health check, and whatnot. So in terms of container, we got our answer in Kubernetes. So Kubernetes is going to help us to manage this entire container environment. It would take care of the load balancing, auto scaling, health check, deployment, orchestration, and everything. So to understand a Kubernetes infrastructure, we'll divide it into two parts. One is the hardware and another one is the software. So under hardware, we'll study about nodes and the cluster and the volumes. And then under software, we'll know about pods, container, deployment, ingress, etc. Okay, so what is node here? We say nodes. So node could be the smallest unit of your Kubernetes hardware structure. So every single machine that we use in the cluster can be called as a node. Now, doesn't matter it is on hardware machine or it is on cloud or it is on virtual machine. All we need is a set of RAM and CPU, right? And we can use as many as nodes as we want here, right? So how does help us? So this help as we can pull them together into cluster. So cluster could be a pool of nodes that help us to maintain our program. So let's say I published my program into 4 different nodes. Now one node goes down, then my cluster would be intelligent enough to shift that workload on other 3 nodes, right? So this gives us a very reliable structure for our containers. So altogether, this pool can be called as a cluster, and we can say that these nodes pulls together their resources that we said like CPU and this RAM together to create a more powerful structure. But as I said, like this cluster is intelligent enough to shift my program workload to other nodes when if in case one node goes down, right? But what would happen to the storage? What would happen to the data? So if one node goes down and this structure, this workload is shifted to other 3 nodes, will it be able to find out that same storage? Probably not, correct? So in this case, to make our storage permanent, we need persistent volume. So we connect and persistent volume to our cluster. Now, this persistent volume could be on cloud, could be on physical, anywhere, doesn't matter. But that helps us to make our environment or our data be available to our cluster irrespective of the nodes. So even if our node goes down, doesn't matter, the data location is going to be the same. All right, so till now we spoke about the hardware structure of Kubernetes. And now we are going to have a look at the software structure. So we'll start with the containers. So we all know that any program and its all dependencies can be bundled into a single file. And this file we can share over the internet and anyone can download the file that is basically a container and deploy it in their environment or the infrastructure, and they will get the same identical environment that we have packed, right? So they don't have to install that program and its dependencies separately. It's all packed together, correct? So now the program running on Kubernetes are packed as a self-contained Linux execution environment, right? So in this package, we can actually put multiple programs that we can add into the single container. But why we should limit ourselves into single container when we can go for the multiple one on the same pod, correct? So here we prefer to go for to create a smaller container than one large one, as each container has a tight focus, updates are easier to deploy, and issues are easier to diagnose. So we always prefer to go for a multi-container environment. But Kubernetes doesn't run container directly. Instead, it wraps multiple containers into a higher level structure that is called pods. So any container in the same pod share the same resource and local network. These containers can easily communicate with each other as if they are in the same machine, while maintaining the degree of isolation from others. So I have created these two, you can say pods here. In this pod, I have put two containers, and these two would be free to communicate with each other while they would be maintaining their isolation as well. However, pods are the basic unit of computation in Kubernetes, but typically they are not launched directly into the cluster. Instead, they need another layer of abstraction, and that is what we call deployment, right? So a deployment is the primary purpose of the deployment is to declare how many layers of replicas I need, right? So when I create a deployment, and I have to mention how many replicas of my program or the container I need, right? And automatically it would spin up the requested number of pods and it would monitor them. And if a pod dies, the deployment would automatically recreate. So let's say in my deployment, I mentioned that I need 10 replicas, right? So it would spin up pods according to my request. And if any of the pod die, it would transfer this or recreate another pod according to my requirement, correct? So this was container, pods, and deployment. So let me try to make it even easier for you. Okay, so let's imagine I have this manager, okay, and then I have these three workers. So I generated the key and I connected them to my cluster. So altogether, three nodes are added to my cluster now. So I have one manager, three workers, one cluster, inside one cluster, right? And this is where my service is going to be published. So here you see, this is my service that I'm going to publish from here, or that this IP is going to be uh, attached to my load balance. All right, so now let's have a look at the software part. So I created a deployment file. Inside that, what I should have? I should have pods, correct? Inside that, what would I have? Containers, right? So in my deployment file, I mentioned that I need 3 replicas for this container and 4 replicas for this container. So this is basically is going to be a YAML file. Inside that we'll build a deployment, and there I would mention how many pods I need, how many containers I need, and how many replicas should be maintained. Why I'm saying it should be maintained means if any of this replicas goes down, like now my deployment would be, my cluster would be intelligent enough to assign these replicas to the workers. So let's say I said I want 3 replica for this container. So my cluster would now decide which worker should host which replica.
And in case one of the node goes down, my cluster would be intelligent enough to shift that program to the other nodes, right? So this is the deployment file. Inside that I have pod, inside that I have containers, and I can mention how many replicas we want to manage. And this cluster would be taking care of my deployment file and the deployment instruction, correct? So guys, this was hardware and the software infrastructure of Kubernetes, and I really tried to make it the simplest terms that I can explain it. And thank you so much for watching this video. You guys have a wonderful day ahead. Bye-bye.